Good morning, good afternoon, or good evening, depending on where you are, and welcome to Nautel's introductory seminar of our brand new NX5 and NX10 series transmitters. I'm Chuck Kelly, and I'm very, very proud to be here with you all today. Along with me is Mr. Alex Morash, the AM project leader. Hello, Alex.
Hi, Chuck. How are you?
I'm wonderful. Some of you may recognize Alex because he's also the father of the wildly successful VS series. So go from one great introduction to another, Alex. Okay, so we're going to talk about today. We're going to try to keep this to 45 minutes or so. Hopefully you've got that much time. If not, bear in mind that we put these up within a few hours onto YouTube. You can get at them from our website, and you can see them in entirety. So if you've got to duck away and you miss some and you want to go back and check it out, you can always find it on YouTube. All right, so we're going to talk about the things we're talking about right now. We're going to talk about the NX series general concepts. We're going to talk about how these products are digital. We're going to talk about efficiency and how we get there. We're going to talk about how to control the NX5 and NX10. We're going to talk about the advanced capabilities of the system. Then my favorite part, we're going to go live to an NX10 sitting downstairs in our engineering lab. We're going to talk a little bit about Nautel support, and then we're going to take your questions. And your questions can be accessed from the little screen on the left, or on the right-hand side, rather, of your screen. You can type in your questions, and at the end, we're going to try to answer your questions as we can. If we can't answer your question during the webinar, it's all kept track of, and we will send you an email with the answers to your questions soon after your webinar, after the webinar is over. So this is kind of just my experience of what's in the market today. There's AM transmitters seems to be a very, very broad assortment of some things that are classic designs, nothing more romantic than a glowing tube, I suppose, to some relatively recent design. But see, even the recent designs aren't all that recent. I've got kids older than or younger than some of the designs that what is currently sold as a current design, and of course there's even some really, really antique stuff out there. Now, it's probably the lower right-hand corner is probably an exaggeration, I hope, but there is some older stuff out there. And one thing that's very interesting to understand is the efficiency of these transmitters varies wildly. A plate-modulated tube-type transmitter could be 40 to 50%. And today's best transmitter, well, the new NX series we're introducing, is 83% from RF. Sorry, is that 86%? 86%, even better than I imagined. From AC to RF. So the NX5 and the 10 stands on the shoulders of 20 megawatts worth of NX that's out there in the marketplace. We've shipped 20 million watts total power of the NX series since the NX was introduced just a few years ago. They're very efficient, as I mentioned, 86%, very compact. They're advanced, and they're fully into digital, whatever route digital chooses to take in the future. The NX series itself was designed from the ground up as a no-compromise AM system. It has the industry's top efficiencies. Nobody has better efficiencies than the NX series. It's proven to be robust. It includes the world's first adaptive pre-correction in AM transmitters. It includes a RF spectrum analyzer built in. It uses 1.8 megahertz direct digital modulation, has an intuitive touchscreen interface, also known as the AUI. And if you know how to use our AUI in an FM transmitter or our TV transmitters, you know how to use it in the NX series. It's an ultra-compact series, and all VRM modes plus HD radio are all supported. And these transmitters go from our 5 kilowatt now all the way up to 2 million watts in a single box. Well, a few boxes put together, perhaps in the 2 million watt size. And we won the Cool Stuff Award, and we're very proud of that. So to put things by comparison, the Gates Airflex Diva DX10 takes up a lot of floor space in a transmitter site, as does the BEAM10, and the NX10 is the smallest of the bunch. Looking at it from a block diagram standpoint, it's very, very simple. We're using the exact same NX series modules as was used in all the other transmitters. The 2.5 kilowatt very robust, very well proven module continues in the NX5 and 10. There's 2 of the modules in a 5 kilowatt and 10 in a 10 kilowatt, or rather 4 in a 10 kilowatt. Yeah. Use exactly the same kind of driving and the same kind of combiner. It's using 6-phase multi-phase PDM, and we use the same exciter. We have an optional exciter in these units. There's one provided with the transmitter and a second one is optional. The GPS is optional. You have a local control LCD, and then you continue to have the AUI, which can be accessed via the web. And we'll talk about all the broad number of audio inputs. We have the power supplies, big chunk of iron, which we'll show you, which a lot of people like, getting rid of, especially in an AM site with the amount of lightning that comes down at AM sites. I mentioned that dynamic pre-correction is standard in the transmitter. Alex, do you want to kind of walk us through the schematic, the block diagram, I should say, on the right-hand side?
Yeah, sure. So basically what happens with the dynamic pre-correction is we take a sample of the output of the transmitter, and that is compared to the ideal waveform that you're trying to transmit, and then we have a look at the difference and then figure out what kind of correction curve has to be implemented inside the exciter to adjust for the distortion that's,
and that's stored in the lookup table, the LUT there.
That's right. Yeah.
Okay, and so we're actually, it's self-correcting for anything that changes, and the things that we're correcting for are envelope equalization, AM to AM correction, AM to PM correction.
That's right.
So AM to, tell me about envelope equalization. What does that really mean?
So that means that basically from the filter that's used in the power amplifier's modulator, that causes some frequency response in the audio that's being transmitted through the transmitter. So we apply an inverse filter to try to compensate for that frequency response and get a better frequency response through the transmitter.
And AM to AM correction, people who have used the early simplistic versions of PDM, they would know that as PWM nipple. Okay. It get where the PWM carrier, as it approached 100% negative, tended to go to 0 or 100% negative right away, and caused an extra bit of distortion. And there's just none of it in this one because of that correction.
That's right. Yeah.
And AM to PM correction, is that what we used to worry about when we talked about AM stereo not having good performance?
That's right, yeah, IPM basically.
Okay, so it gets rid of that.
That's right.
Okay, very good. So this is what I was saying, the PWM nipple. There is no visible distortion in the point at which we approach 100% negative modulation with the AM to AM correction. Couldn't be cleaner.
Thank you.
And this is the card that controls the transmitter. This is the brains of the transmitter. And all the audio feeds into this card, and the 2 digital exciters that are possible plug into the bottom. One is standard, one is optional. And one thing that I love about this card, correct me if I'm wrong, but I've done some looking. I've looked all over this card, and I have not yet found a potentiometer.
No, there's no analog pots on the card at all.
Well, there's certainly some variable capacitors or variable inductors.
No,
right?
No,
right.
and
if I go down to the exciter, it's the same thing.
That's right, yeah.
So this is the true concept of a purely fully digital system. Everything is done with numbers at the end of the day. And it provides precise and reliable RF and audio drive. It has a broad range of audio inputs, including 2 AES EBU inputs, analog left and right, and INQ inputs.
That's right. Yeah.
And it has an optional GPS input card for the ultimate in frequency accuracy. So for instance, if you want to do an AM SFN, you'd put the GPS on there. And there's parallel remote control and a full web server TCP/IP control, also known as the AUI. And going back to the same module we've used across the range, the left-hand side of this card is the modulator. And we'll show a schematic or a block diagram of that in a second. And the right-hand side of the card over here is the RF amplifiers. And the key bit of all of this is the H-bridge, which is 4 200-ampere field effect transistors, which are screwed in here. They're actually replaceable with just a screwdriver. And And we control those, and this is part of the magic on the efficiency of these things. As I understand it, we control the gates of each of those transistors independently from the control card. So that, in other words, in a lot of other designs, these would be ganged up. So these two would be driven by the same, and those two would be driven by the same. We're actually controlling them independently so that we're sure that there's no, the switching does not occur when there's voltage across it. Is that right?
Yeah, there's pairs of transistors that switch together, basically, but
okay.
Each side is controlled separately.
Okay, and so this allows the efficiency, which is 98% DC to RF in the module itself.
Mm-hmm. Yep.
So these things don't, even when you're running a very high power transmitter, you pull one of these modules out, you feel it, it's relatively room temperature. There's hardly any heat to it at all. And I have actually seen the continuous power rating of this module. If you sit there and just put full signal into it at full bore, you can get 12 kilowatts out of this module.
Yeah, so the RF amplifier section, that's certainly what it's capable of.
And
we run it at only 2.5 kilowatts in a transmitter.
And part of the reason for that is to allow for peaks for modulation capability.
That's right.
But part of it is also because those FETs have a lower on resistance when they're very, very high current capable. Mm-hmm. And that lower on resistance improves the efficiency of the module.
Right, exactly.
Okay, very good. And so here's the drawing. Would you like to explain the modulator, the three phases here you can see, and then the H-bridge, how that works?
Sure, yeah. So the modulator FETs are controlled by our PDM, so the digital modulating signals that comes into the power amplifier, mm-hmm. And they essentially switch the input of into the input of the modulator filter, and they switch between 400 volts DC, which is our B+ supply, right. and ground or 0 volts. And there's three PDM phases that come into the amplifier, and they are added together through the first inductor of the modulator filter,
which is this range of inductors here.
Yep.
And then there's a pi filter there.
Yes, that's right. So that filters off the harmonics of the square wave.
Okay. And what is the typical frequency of each of these things, or the total frequency, total effective frequency? Is that where the 1.2 megahertz? Whatever it was.
1.8 megahertz.
1.8 megahertz. Yeah.
Yeah. It's basically the sampling rate of the PDM. So because the transmitter has 6 PDM phases, they switch at 155 kilohertz each. Yeah, and then each edge of the PDM essentially samples the incoming audio signal.
Okay.
That's our overall effective sampling rate.
The benefit of all that is that this filter doesn't have to be right above the audio range, so you end up with a lot of modulator bandwidth.
That's right. Yeah. So,
and you don't have a very stringent filter to deal with.
Right, and yeah, it improves our linearity basically for digital.
And our group delay, I imagine, too.
Yes.
Yeah. And the other thing that I think is these three, just to clarify, these three are all 120 degrees out of phase. Is that right?
That's correct. Yes.
Okay. All right. Very good. I'm glad I understand this. Okay. Now explain the H-bridge to everybody.
Okay. So again, we have some digital RF drive signals that come into the power amplifier, mm-hmm. And then. Those go through some gate drive transformers just because some of the FETs are sitting at higher voltages than
sure.
They're not ground reference, and those switch the FETs at the RF carrier frequency. It's a Class D full H-bridge amplifier, so that it switches pairs of FET switch at the same time.
Right. So the way this works is the power is coupled off the center here. So therefore, Q3 and Q2 might be on, while Q1 and Q4 are off.
That's right. Yes.
And then the whole thing switches, and we do it at a time. We do the switching at a time when the waveform is at zero potential across the device, so we don't have losses.
Right. It minimizes the dissipation in the
sure.
Yep,
which is why we get 98% efficiency.
That's right.
Cool. Okay. And this is just interesting to see how things are from the side. There are, again, no adjustments, no potentiometers, no variable capacitors. It's broadbanded, the entire AM band. Matter of fact, the entire transmitter from exciter through modulator, through the power amplifier, through the combiner, is all broadbanded. The only thing that's changed when you change the frequency of this transmitter is the output filter.
Yes, that's right.
Cool. These modules are hot pluggable, and there's heavy gold connectors on both sides, and the heatsink is 2.5 times the required size. And you have these silicon carbide modulator diodes. And I see those up here. What do those do?
Well, they're basically, they switch extremely fast. So there's, again, it helps to minimize the dissipation of the power module.
So they're actually protecting the device against ringing? Is that what it is?
Yeah, they allow the current to continue to flow through that first inductor after the FET is switched off.
Okay. Yeah. Cool. Okay. And then we have balanced RS-422 modulator and RF drive. So the 3 phases of modulation plus the RF drive are all coming across a connector with RS-422 levels, I guess.
Right. Yep.
Okay, good. And this is showing how the direct drive digital modulation manifests itself.
Right.
And it really shows you the difference. If you imagine trying to filter out the components of that switching frequency versus having to filter out the components of this switching frequency, you can see that modulator bandwidth, which is really, really important when it comes to digital broadcasting, for instance, is no issue at all.
Right. And you can also see, I guess, how many additional times the input waveform is sampled in the lower waveform than the upper waveform.
Absolutely. So that gives you better I guess, distortion.
Right.
Yeah. Okay. Great. So now you've got the output of all these power modules, and you go to combine it. Want to explain how this works?
Yeah. So it's a transformer combiner basically. So the primary of the transformer is 2 turns. The secondary is 3 turns, and it's a Litz wire transformer that just allows the high RF current to be drawn through the wire.
Gets rid of skin effect.
That's right.
Yeah.
Yeah.
So each one of these sets of toroids is corroborated to one of the modules.
That's right, yeah.
So this series starts at ground over here and ends up with the RF voltage over there.
Yes, yeah. Basically the voltage of output of each power module gets added together as you move through the combiner.
Okay, and one of the things that I love is this module isolation relay. So what allows the system to continue to work during hot swappability when you pull out a module is this module isolation relay.
Exactly.
And it's one of only 3 types of moving parts in the NX. The others are the fans and the B+ discharge relay.
Right.
It's kind of cool. That's really kind of cool. Okay, so then this is where the modules plug in, and that's that module relay, that module isolation relay right there.
Yep, that's it.
And you've got some fuses on the board, which are relatively easy to get to and change if you need to, that protect the B+ voltage going into the module. Is that right?
Yeah, that's right. It essentially isolates the power modules on the B+ bus.
Perfect. Okay, and then this is the output network. So behind the front door, inside, or behind the rear door, I guess, but behind the front door is how you really get. This is where this picture is taken. These are the inductors associated with the output filter.
Yeah.
Want to explain? It's two T-traps.
That's right. Yeah. So it does. The filter does double duty as an RF filter. It filters off the RF harmonics, and it's also a matching network to match the ideal PA impedance to the 50 ohms that we want to see at the output of the transmitter. It also includes a third harmonic notch just to make sure the third harmonic level meets the regulatory requirements that we're trying to meet. And this filter has been updated a little bit to make it a little bit easier and more consistent tuning-wise. So we've added some bars. You can kind of see them.
Yep, this one's probably the easiest one to see. So there's a bar that comes out here, and there's a clamp.
Right.
And that means that the little flexible strap that's usually in these kinds of inductors is very short.
Yes.
And it makes it, much, as you said, much more consistent in the way that it's tuned.
Exactly.
Okay, excellent. And on the back side, this is where the capacitors go.
Right, yeah. So these are the 2 capacitor banks that are part of the 2T networks of the filter. And then the strap in the middle is the third harmonic notch.
So this strap here
Yep.
is actually an inductor.
Yes.
And as we change the frequency of the transmitter, the position, I suppose, of that little thing right there changes, perhaps.
Exactly, yeah. Essentially, it's supposed to resonate with that second capacitor bank there at the third harmonic frequency.
Okay. Now, one thing, tell me about these capacitors, because it's not normal that a lot of companies use these. I've seen the mica capacitors with the tar in them and all that kind of stuff, and then they have pretty dramatic results when lightning hits. Tell me about what these are.
So these are ceramic disc capacitors, essentially, and these capacitors are actually the same ones we use in high-power NX, so they're significantly overrated for the job that they're doing here. They're very high voltage and high-power capacitors.
Okay, very good. And the whole filter is very low Q, which means that we have less problems in trying to optimize the system for HD radio or for DRM particularly.
Right.
Okay, very good. And you can change, so let's think about just for a second, between this page and this page, what changes when you change the frequency? You change some capacitors and you change the position of some of those.
That's right.
And that's pretty much it.
And that's it, yep.
Okay, so in less than a couple of hours, I suppose.
Pretty straightforward.
Okay, very good. Now, this is the schematic of what we've just looked at.
Yes.
I would like you to do something for me. I'd like to look at, you're now a lightning bolt coming in from the antenna, coming down and striking the tower, and you come right into this output port right here.
Yes.
What happens?
All right, so the first thing it's going to encounter is the carbon ball gap. So that's adjusted to fire just over the peak voltage output of the transmitter. So that's
carbon ball gap can absorb tremendous amounts of energy, but it's kind of slow.
Right. Exactly.
Okay.
Yep.
So all right. So it's slow, but high number of joules can be dissipated.
Right.
All right. Then next.
So then we have the directional coupler, which measures reflected power. So it can tell when that ball gap has fired, and it also can tell when there's energy coming down the spout, essentially.
Okay.
So that will cause the RF drive to be switched off in less than an RF switching cycle, so that the RF FETs never actually switch into the energy that's coming down the spout.
It's an interesting point because what I have learned over the years is that the typical failure mode of an AM transmitter, particularly a Class D H bridge, it's the power in the power supply that destroys the transistors more often than it is the lightning itself. The lightning itself creates a DC short at the output of the transmitter because the ball gaps and things like that short. But those H bridges, you destroy the symmetry and the switching synchronization, and you start drawing current from the 400 volt supply straight on down to ground and destroying those transistors in vertical pairs. This system that you just talked about that shuts down within
50 nanoseconds.
50 nanoseconds.
Yeah, it's very fast.
it prevents that from happening.
Right.
And that's pretty cool. Okay, so now you've got a static drain choke.
Yeah, so that's not really for lightning. It's more for static buildup on the tower, but that happens sometimes too. So then we have the series resonant high pass section, which is it's a high pass filter. It essentially presents a higher impedance to the frequencies at which lightning occurs.
What's the cutoff frequency?
So it's I don't know what the lower cutoff frequency there.
Okay, so but it's below the low end of the AM band.
Yes, for sure.
And it's above where the concentration of energy is from lightning, which guess
is about 10 to 100 kilohertz.
Right.
In that
Okay.
range.
All right. And it also does one more thing, as I understand it. It also delays the pulse.
Right. Yeah. Yeah. So one of the additional one of the additional benefits of having the whole filter in between is that we can detect the pulse at the output before it has time to travel through the filter to the power amplifiers.
That's very important because then you've already shut off the power amplifiers by the time the lightning pulse comes in.
Exactly.
Really cool. Okay, now we have this calibrated fast spark gap, which is made of pressurized tritium.
Right. So the tritium is essentially, in that spark gap, there's some free electrons floating around. So that means the spark gap will fire a lot faster than just any air spark gap. And the point of having it at that point is that when it fires, it presents a short circuit across that capacitor bank and essentially presents an inductive load to the power amplifiers, which they're happy to switch in.
Okay. Now, what's really cool about that is going back to what we said about the carbon ball gap. The carbon ball gap is capable of a large amount of power or dissipation, but it's slow. Then we've got this delay in the middle here through the filter, and then we've got a device which is capable of dissipating a smaller amount of power, but it's really fast.
Yeah.
So those things work in sync, and this means that the system is very well protected. Now, what happens to whatever gets past all of that? It goes into these heavy wires, goes through a couple of loops each time through a couple of toroids, and goes straight to ground.
Right. Exactly.
That's pretty cool.
Yeah.
Okay. All right. And these are those filters we saw, or the transformers that we saw before in the combiner page. Okay. I now understand this. All right. Here's that really cool tritium device.
Yes.
And over here is the carbon ball gaps, which are adjustable,
That's
so that
right.
you can set it up for your modulation and your power level. And there's your
Static drain
choke. Okay. And this is the other bit, which is we can actually take care of reducing the surges that come in through the AC line because we have a phase control B+ rectifier. It's an active regulator, basically, on the input side of the AC line.
Yeah, exactly.
Past the transformer, but ahead of the electronics.
Right. Yep.
Okay, and it can react relatively quickly as well?
It reacts to changes in the input voltage, basically, but it's not really a fast reacting device.
Not in the nanoseconds range.
No, yeah, we still
but
recommend
faster than your average ADR, I suppose.
Right, yeah.
Okay. Yep. Okay, so it's kind of like having an ADR in the transmitter,
yeah,
in a sense. Okay, and it also provides the ability to turn on the transmitter slowly, so you don't have large amounts of surge current.
Yeah, the inrush current is reduced because essentially it provides a soft start of the power supply.
Okay, very good. So this is the big chunk of iron I was alluding to before, the NX 5 and 10 power transformer. Is the 5 and 10 power transformer different?
Yeah, it is. The 5 power transformer is
a little smaller. Yep, okay. And the voltage ranges, you can connect this in Y or delta, but it's all three-phase.
That's right, yep. And so the standard voltage ranges are the one that's shown here, which is 380 or 480 volt standard, and we do have another standard transformer, which is a 220 volt transformer.
Okay, so you order it either in Y or in delta. Okay, very good. And now cooling is very much like the NX series. We have DC fans with ball bearings, very long life, and they have 3 wires on every fan, and the reason is because there's a tachometer on every single fan inside the transmitter.
That's right, yep. They're all monitored by the main controller.
And they're really easy to change out, but you shouldn't have to do that very often because they last for 9 years on the average.
Yes.
Okay. And in a whole 10 kilowatt transmitter, at 86% efficiency, only 1.4 kilowatts of heat is produced, which is about the same amount of heat as in a typical 2.5 kilowatt FM transmitter.
Yeah.
Cool. And the air is drawn in from the rear through a disposable paper air filter that can be changed without turning the transmitter off.
That's right. Yeah, it's very easy to remove and change.
Okay. So we've got a couple of power supplies for the low voltages. One is, 48 volts and 15 volts?
That's right. Yep.
Okay. And those are SMPSs, switch mode power supplies, that are fed from the output of the transformer. So you get the benefit of the transformer.
Yes.
In terms of surge protection.
Yep.
And then you can see how the whole power supply system works. You've got the phase regulator that we looked at here, and then we've got the filter bank here, and we have the choke input filter chokes there, and that's for discharging the capacitor so you don't get, if you open the front and back of the door transmitter quickly, you don't get zapped.
That's right, yeah. There's 400 volts there, so you don't want to touch that.
Very good. And down here, this is the 3-phase LEDs, so you can see that whether the door is closed or not.
Yes.
And you can tell whether there's all 3 phases applied to the transmitter. Very easy and safe way to tell. We thought that was those LEDs, and they're like an inch in diameter or something, were better on the back of the transmitter down where you're about to enter, as opposed to on the front of the transmitter in a little display.
Right.
Okay, good. 86% efficiency, a big deal. You know, one of the things that people don't necessarily realize until they go through a return on investment analysis is how quickly an efficiency improvement can pay back the actual cost of the transmitter, let alone the cost of replacing tubes or all that sort of thing. And it's even better than 86% because at the end of the day, we also provide, at no charge, the modulation-dependent carrier level, MDCL, that a lot of companies charge $5,000 for. We make it standard, and all 5 algorithms are included. And the typical performance of MDCL saves you 30% on top of that 86%. And there's been no discernible, lots of tests been done, lots of consulting engineers run around with meters and audiences have listened to various amounts of various different algorithms, and nobody's been able to tell a statistically significant difference between it in use and not in use. And our customers on the higher power NX transmitters have proven that themselves. So with the reduced electrical cost, the purchase price of an NX can often be paid off in just a few years when compared with older tube and solid state designs. So pretty cool. There's a lot of advanced capabilities. We're blowing through time really quick, but it's good that we were able to get down and dirty with some of the good stuff that goes on inside the transmitter. I'll put this screen up and I'll leave it for a second, and I hope everybody's going to read it because I'm not going to read it to you. But we're going to save our time for the demonstration. One of the cool things is this AUI has been incredibly successful around the world since we introduced the very first transmitter with an AUI. And there's over 5,000 of these devices equipped with our advanced user interface in use around the world. And they go from our 150-watt UHF transmitter to our 300-watt VS series transmitter, all the way up to 88 kilowatt FM and 2 megawatt AM transmitters in the NX series, and all the way down to the new 5 and 10 kilowatt. And you know, what's cool is if you know how to use one of them, you pretty much know how to use all of them. And that's very reassuring when you get an email or an SMS at 3 in the morning and you need to pull up your computer and figure out what's going on. It's nice to know. I've got customers who have 30 of these things, and they can log into any of them from their bedroom if they want to, which is a lot nicer than pulling on a coat and going out to the transmitter site. So these transmitters include live wire inside. The NX series is the only AM transmitters that I'm aware of that include the digital audio standard created by Telos Omnia Axia and supported by so many companies now. The NX series supports live wire. It also supports Shoutcast and Icecast. Why would you want that? Well, if the transmitter, if your STL goes down, the transmitter can automatically detect the silence. You can define what the silence is, how much time and at what percentage. And then if your station is webcasting with either Shoutcast or Icecast, and between the two of them they've got 77,000 or something like that stations around the world broadcasting that way, you can program in your web address and the transmitter will suck that in and put it on the air for you as a backup. And what's more, if your studio loses power, then what we can do is you can plug in a USB stick in the back of the transmitter and you can create a playlist, and the transmitter will play that playlist and keep you on the air. Now, obviously, if the studio has lost power, you don't have a webcast, you don't have an STL, you've got to have some sort of alternate thing, and this transmitter's got your back covered. All you've got to do is provide a memory stick, and you can have up about 500 files or something like that. It'll be supported with this system. And you can continue to upload new files to the system through the AUI and change the playlist through the AUI. So, you know, if you need to change the weather forecast or put some sort of news bulletin up there, no sweat, you can do that, even if your transmitter site is dark and people are walking around with flashlights. Nautel has been a leader in digital radio. And both the DRM arena, which covers a lot of the world, and the HD radio arena, which covers North and South America primarily. We have written the book on advanced PA, PR, and linearization algorithms that provide more RMS power from a given power transmitter with better MER. And we've gotten continuing development. We continue to put development and resources into this. Brian Walker's paper from last year's NAB is an excellent example of this. And I believe we're still the only transmitters out there where you can feed true digital INQ signals directly into the transmitter and not have to do it with mag and phase. And that's a big advantage. And all modes and bandwidths are supported, including simulcast DRM, 20 kilohertz DRM, and that'll cause most transmitters terrible fits, is that 20 kilohertz DRM, and in the simulcast for that matter. And all digital HD radio. A lot of Nautel transmitters were used in the tests that were done in the last 6 months or a year for all digital HD radio. So we're very proud of that. And we built in a tool into this series of transmitters on all the NX transmitters that's an MER instrumentation tool that's basically a constellation view but allows you to select individual sets of carriers and determine the MER in each of those sets of carriers. And let's do this right now. Let's switch over to the AUI that's currently in use downstairs, and I will walk through this. So this is a transmitter that's on the air right now in analog mono. You can see here the Smith chart, and even if I zoom in, you'll see that our dummy load is performing pretty well.
Yeah, it looks pretty good there.
It looks pretty good, yeah. A real antenna is going to look like a curve, and the advantage of the Smith chart is you can actually see the orientation of that curve, the cusp orientation, if you will, and most transmitters will respond to a sweet spot, a particular direction of that cusp that improves the performance for digital broadcasting. You can see here, this is the mask for an AM station. You can see here we're doing pretty darn good on that mask, and that's pretty typical. If I go into, in fact, let's switch over. Let's just on the fly switch to HD radio here. Or hybrid rather, and we'll switch to this one. Yep. And now you're going to see the HD radio sidebands start to come up. And let's go ahead and take this spectrum analyzer up full screen. And you can start to see the kind of performance we have with this transmitter. Note we're still making 10 kilowatts. Note that what we're seeing down here is probably about 80 dB below the carrier at the moment because it's 100 dB top to bottom. And look at the amount of mask clearance that we've got there. That's probably about, I'd say, 15 dB below the mask at that point. That's pretty good. You know, there have been a number of derogatory comments in the past about the performance of AM transmitters and the amount of noise they cause to adjacent channels. It'd be pretty hard to hear the noise on the adjacent channels with this kind of signal. You'd be a good neighbor if you had this transmitter and wanted to take advantage of HD radio. So let's put the spectrum analyzer back in its box there. This is the AM to AM correction. So this is dynamically showing us how the transmitter is compensating. This is basically charting the lookup table.
Right, yeah, that shows the lookup table.
Yep.
That's saved in the exciter, basically.
Now that we have a little bit more bandwidth, by the way, we're actually seeing a little bit more activity out of our spectrum analyzer. Yep. How's that? That's cool. And this Lissajou is looking at INQ at the moment, but if we go back to analog, and we'll go to analog AM stereo. Yes, CQAM is built in. It's standard in this transmitter. We actually switch to left and right audio, and you can see the familiar analog Lissajou. This is cool because from a distance you can tell whether the station is in mono, it's out of phase, it's one channel is missing, all that stuff instantly, even from a distance, even without a pair of headphones, you can tell. So over here is a set of meters that we've configured. We can actually make them be whatever we want. So I can, for instance, choose from all these settings that are dynamically being adjusted. You can see that settings change a little bit as time is going by here. So dynamically we're monitoring all those things, and that's just the controller. This is the big difference between the AUI and a lot of other transmitters in the marketplace, is that we are looking at so many things. This is not your grandmother's remote control system, you know? This is really giving you tons of data, the data that would help you in being able to diagnose this transmitter from a long distance and figure out what tools and parts to put in the car before you head out. So we're seeing all of these things on each individual module at the moment. It's truly revolutionary. And then let's continue on here and talk about the types of things that are available on the menu. I did one thing I didn't want to do. Let me switch out of this for a second. Let's go back home. I wanted to show you what other instruments were available here. So these are the other instruments that you can also pull up and put in these 4 quadrants that are the instrument panel on the AUI. And so I'm going to choose, I think that one was the Lissajou. I'll put the Lissajou back. Now we'll bring up the menu, show you all that stuff that's there. Alex, from a high-level view, what kind of things should I show folks?
We can look at some of the preset settings. If you want.
So here's where we would configure up the transmitter, the frequency, the power level, the audio input source, if it's running in digital, what the digital settings, and what do we do in case of a silent sense, basically. Yep. Okay, and all of these can be set in. There's what, 60 settings, 62 settings, or something like that?
62 presets, yeah, that you can set.
So you've got more than you could ever use. Yeah. If you're a station that needs to go from a high power level to a lower power level at night, or even lower power level pre-sunrise, that can all be accommodated in the presets. And then you ask, well, where do I, how do I set that up on a timer? This is where you'd set up the scheduler. So you'd schedule automatically changing a playlist at a particular time, and you can go ahead and program it an entire year off of your license. It typically will tell you what the time of day that you have to go from one power level to another power level in each individual month, because it changes on when the sun comes up, right? So you can program all of that in ahead of time and just be done with it. And one of the other cool things about this transmitter is this transmitter can actually send you, where is it located? I don't know.
What are you looking for?
I want to look for how I send an email or an SMS.
Okay, so that's in user settings.
Okay, there we go. So here's where the network is set up.
Yep.
Now, does your transmitter today have this screen? And then over here you can set up what configuration you're going to have for email, including doing authentication, so your username and password for your SMTP.
Right.
And then over here, what you want to send emails about. So you could have one email that goes out and says the antenna VSWR is high, and another email to a different person that says, I just had a silent sense. Program director needs to work on that guy who's falling asleep at the studio.
Right. Basically, any alarm that you see on the transmitter, you can set.
So you can set up all the alarms here and say what's going to go, and who's the email that one is going to go to, and so all that kind of good stuff. And up here, in order to make sure that you're switching your power levels at the right time, we've set up the time, and we've set up NTP clients. So the transmitter is automatically synchronizing itself to the atomic clocks. And so that's really cool. Nautel phone home. So this is part of the Nautel phone system, which I like to call proactive customer service. Basically, the transmitter tells us that you have a problem probably before you know you have a problem. And we can start to learn about, and when you call up, we can already be aware of what's been going on and look at the logs. Now, you have to give us permission to do this. It's disabled by default. But if you click that, it starts communicating through the internet to our servers here in Nova Scotia, and it allows us to help you support your transmitter even better. All right, what else should I talk about? Here's the logs. One thing I really like talking about. So I have 1,983 logged events in here, and if I hit the log manager,
I think it'll save up to 20,000.
Okay. And I hit copy logs, I get this really cool message. So the what do they call that? The clipboard on my computer here, this notebook that I have on my desk that I'm presenting all this on, the clipboard, if I go into Excel right now or Word and I hit Control-V or paste, the whole log, all 1,900 events, is perfectly pasted into that document, and I can then send that off to Nautel, or I can send that to the general manager as proof of how good this thing's working, or whatever you can do. It's got all of that functionality built in. This is not your grandmother's AM transmitter. What else should we talk about, Alex?
Well, we can show it running in DRM mode.
Oh yeah, we forgot to do that. Just because we can. So we're going to go down here and show 9 kilohertz DRM. That's the standard system that is in use around the world. Yep. And that's the DRM mask that is popped up. I'm going to enlarge this up, and you'll notice that we continue to improve. That's the adaptive pre-correction as it works. And now we're showing the typical 20 TP under the mask that we're sitting there. Look at this. Look at the cleanliness of those skirts.
It's pretty nice.
It's amazing. It's amazing. Okay. All right. Is that pretty much what we wanted to show, because I want to give time for people to get their questions answered, and I noticed that we do have a questions pane. So, available in single and three-phase power input? Not yet. This transmitter that we're introducing today, the 10 kilowatt, is available, and it will be shipping in May in three-phase only, which is probably the right thing you ought to do. But single-phase potentially in the future, but right now it's three-phase.
Right. And
the 5 kilowatt version will be starting to ship in June, again in the three-phase version to begin with, and eventually in single phase. In the shipping version, will the inductors in the output network be silver plated?
No, they won't. No, we don't silver plate the inductors.
Because we don't find that the size of the conductor or the pipe there is already large enough so we don't have a problem with skin effect.
Exactly.
Okay. Are there 208 or 240 volt mains input options, especially in the 5 kilowatt model?
Yeah, I think the 220 volt transformer that we provide has taps in that range.
Okay. Is the AUI accessible with mobile phones? The answer to that is yes, but you got to have a cute little app that kind of does it offline. There's a number of apps, and we'll send you some information. But all of these things, in order to take advantage of the ability to have dynamic, fast graphics on the screen, utilize Flash. And Flash, it doesn't work in a lot of mobile phones, but there are apps now that you can get for $2 or something in the App Store, both for Apple products or Android products that do allow you to use the AUI in full graphics, and it just works great. Should I retire my AmpFet 5? Good question. I don't think any of these things ever goes to the dump, actually. We keep providing parts. We continue to provide support. I think we're probably the only company that still supports products of that age. I really do think we are. But yeah, you need to do the analysis, Brad, and figure out about the cost savings that could be had in the electrical savings in doing that. Thank you for asking that question. I love that. Let's see. I suppose that the studio loses power if the transmitter site is web remoted and with the USB connected to the music ready to be played when the system loses signal. Will it know that the signal is back and switch itself back to the STL when the signal comes back?
No, the transmitter.
Not yet, but we're working on that.
Right.
That feature was introduced to the GV, and we hope to port that feature back into this product in the future.
Right.
Okay. Why was the list as you showed us display showing a stereo signal when you were in mono? Because I was feeding it with a stereo signal. The audio coming in was L plus R with a stereo component. Thank you, Laverne. You're keeping me honest here. How does it behave in strong AM fields from near stations? So I understand Oscar's question here. There have been situations where transmitters, solid-state transmitters, were located in the sites that were in close proximity to other high-power AM sites, and you'd get cross-modulation where the power would come in the antenna system and go back out the antenna system after mixing in the output stage of the transmitter. Anything that we're doing here special that might aid that?
I don't think there's anything special.
So if you have that issue, you probably need to put some filters in and deal with those filters. Yep. Does the scheduler deal with daylight savings time?
I don't think it does at this point. Does it?
I think it does.
Or maybe it does.
I think because we're using the Linux system. Let's see if I can find that. I can come over here to this and look at the. 1 second. We go over to System Settings. Nope, that's wrong. Menu.
You're looking for the time?
Yeah, I got to go into the user settings. And here, yeah, I think you set it up. And I think it knows the date and the time, and therefore it bases it based on the Canada's rules. And so we would then choose Halifax, and that would be under Canada, right?
Atlanta.
Oops, so it's under...
Yeah, there it is, Atlanta.
There we go. Yeah, so that one, and I think that switches automatically because it's based on UTC, but then it knows it's in Canada and we observe DST.
Okay.
So, yep, that works. All right. Will Burke be producing a plus remote control system for the low-power NX? Well, SNMP is supported, and Burke uses our information. So they haven't hit us up, but they do work with the NX already. Is that right?
I'm not sure if they have a controller with NX or not.
That's an easy thing. We can provide them the MIB, which is the definition of the things that we're monitoring and what can be controlled as interpreted by the transmitter. Control interfacing for pattern changes. So that would mean using some of the remote inputs to make sure that you don't put too much power into the wrong pattern, or also programming a port on the output to go to create a signal that can go out and change a pattern when the system changes, and that all should be doable by the scheduler.
Yeah, right. Yeah.
Okay, how do you play a sign-on or sign-off spot? You set it up in the configuration, I imagine. So you would have to, in your playlist, you're assuming that I presume you're talking about playlist operation. If you want, you can have, if you're using a regular STL from the studio, you could have the system automatically play a cut, which is set up as a playlist to be a sign-on or a sign-off, and then it could then switch to the next preset, which would then turn the transmitter off.
Right.
That would be kind of cool. Yeah, that would be doable. Is there a UPS option?
There's no UPS option at this moment.
But that's not something. That's something we could potentially work, because
Absolutely.
all you really have to do is to power those two
low voltage supplies.
LVPSs. Yep. Okay. Is there automatic power reduction under high VSWR?
Yes, there is.
You want to describe that for just a second? What happens?
So basically, there's two values that we're measuring for VSWR. We measure peak reflected power and RMS reflected power. So when the RMS reflected power exceeds 4% of the rated power of the transmitter will gracefully reduce its output power to maintain a reflected power level that's acceptable to the transmitter.
Yep.
And then if the peak reflected power limit is exceeded, then the transmitter shuts off and it will come back up immediately and try to come up to a power level that's acceptable.
Okay, great. So we talked about this, daylight savings, offsetting, and auto switching. I believe that all is going to work innately because it's all tied to UTC. Which power phase is the exciter connected to? That's a dandy question.
So the exciter is powered indirectly, I guess, through the low voltage power supplies, which are on the secondary of the transformer.
Right.
So I think
so if you lose a phase on the transformer input, would there still, regardless of which phase you lost, would you still be able to run the LVBPSs and thus the exciter in control?
I'm not sure.
Okay.
That's something.
Good question.
Yeah.
All right, we'll find out and let you know, John. Thank you for that. What's the lowest power level that the 10 kilowatt transmitter can run with good audio?
We're working on characterizing that right now. I don't know for exactly how low you can run it, but we expect to be able to reduce power at least to 10% and maybe down to 1% with reasonable audio.
So you're working on that right now and doing the characterization.
Yes.
Okay. Network rotation chart. Yeah, that's on there. That's the. I believe you're talking about the Smith chart. Yeah. Thank you, Mike. Can there be a second alarm alert log only with critical messages and alarms? Okay, so in other words, if you've got some alarms which are very important and some which are for your information, and if you've got it set that it gives you an electric shock every time some alarm happens, well then you'd probably want to just separate that to be
sure. Yeah, we don't really have that feature at the moment.
Good idea, though.
Yeah,
some of the best ideas come out of these questions. Thank you, Mike. How does or can the log export to an external computer? Well, I just explained that. Actually, you can just pull in the AUI and just drop and then Control V into Excel, and you're done. Can the AUI have HTTPS encrypted access options, or is HTTP unencrypted the only way to do it? At the moment, I believe it's unencrypted.
I think so. Yeah.
Yeah, that's something we are looking into. DST for pattern changes, always overlooked. I believe that's in this. I honestly believe that's part of the NTP synchronization app that's built into this thing. In other words, the clock changes, but the sun doesn't. That's right. That's right. You're right, Chris. Audio is dropping out and back in. Sorry, but it may be that we're looking at each other and turning away from the mics. Bad mic technique. Slap, slap. Remote control, direct interface with other advanced remote control systems. Yeah, SNMP. So that's pretty much the language that people are using, and so that's why. Let's see. Does the transmitter have its own audio processor, or we still need an external processor? Still need an external processor. The Orban Inside is an FM-only processor, and there is not an Orban Inside equivalent at this time in this series of transmitters. How many different power level presets are available for U.S. Pre-Sunrise Authority and PSSA? And that says 62, right?
Right.
Okay, so 62. I hope that does it for you. And can the transmitter email a notification when an alarm condition returns back to its normal status?
I think that's on the list of things to do, but it's not something that it does.
Good idea. Thank you. So that's what, and Canadian DST, I did reference that, Mike, but I meant the same thing with US. I was just explaining for that. And yes, Brad, full GPIO does apply. And I've already gone for 10 minutes longer than I was going to go. But thank you all for your questions. Let's get really quick back to the balance of this presentation, and we will wrap this thing up and let people get to the rest of the day. Now that you've decided you want one of these things, you're going to be excited to know how easy it is to install it. And part of that is pre-installed ferrite on the AC cabling, a la what we've done in the NV Lite and the GV. There's an integrated pallet, so you can actually take your forklift right underneath the transmitter and pick up the transmitter right on the forklift. And even better, we've installed casters on the transmitter so that you can wheel the transmitter around. If you'll see here, this is from the front and this is from the back. There are wheels underneath, and you can wheel the transmitter around. And then all you got to do is rock it forward, take the casters out, and then rock it back down, and then you don't have it wheeling around in an earthquake.
There's actually leveler feet to make that really easy.
Okay, excellent. And the transformer is shipped installed, so those of you who have hernias, I'm sorry it's too late, but from now on, these transmitters roll around and they have transformers in them. So you'll be very happy to know that these, and it's all supported by the best service and support in the whole industry, the Nautel customer service team with our 3 offices in Quincy, Bangor, and Halifax, parts depots all over the place, including next door to FedEx in Memphis, 24/7 live support, live chat, and we've supported and continue to support every Nautel product ever made, no matter when it was manufactured. And I guess the best index of that is a year or so ago when CBC returned the very first 50 kilowatt AM transmitter we ever made for a frequency change and then sent it back out to another location.
Yes.
Love that story. It's awesome. Nautel Phone Home, the proactive customer service that allows us to, that I explained already, that allows us to actually know what's going on before you know what's going on. And just to summarize, it's the NX5 and 10 are the latest in the great generation of NX series transmitters with high efficiency, compact size, advanced features, digital performance, and supported by the best customer service. And the best thing is the last thing, and that is that these transmitters are actually less expensive than the XR transmitters they replace. So not only are they going to save you more power or electrical energy and cost in that regard, but also they cost less than the XR transmitters they replace. So that's the really good news. So your questions we already got to. Thank you for those. You can keep in touch with more information from our Nautel Waves newsletter. Our webinars are online, YouTube, and our Nautel store standing by to help you. And we're always standing by to help you at sales@nautel.com. From the employees of Nautel and for Alex Morash, thank you so much for being here today, and have a great evening.